In this session, we will determine how to find the fringe patterns, how to determine the material fringe constant for a circular disc. Here we have a polariscope. So this is a polariscope setup. So otherwise we call this as photoelastic setup. The experiment on which we perform this is called as polariscope. So look at this closely. We have set of optical instruments. Now here we have polarizer, quarter wave plate 1, quarter wave plate 2, analyzer. I repeat, polarizer, quarter wave plate 1, quarter wave plate 2, analyzer. So these are held at some positions. The polarizer and analyzer are perpendicular to each other. Similarly, you have this quarter wave plate 1 and quarter wave plate 2, one at 45 degrees, another at 135 degrees. Okay. So this is a system in which you have the light which will be transformed into different light, and it will pass through this model which is stressed. Now it is held between two jaws, so it is stressed. When we further increase load, you can observe there will be isoclinic fringe pattern through the analyzer. So what we are going to do now, we have to place this disc like this and we are going to apply load. So this is called a loading frame. Now here what actually happens, the monochromatic light will be converted into polarized light. Okay. Then this polarized light will be converted into circularly polarized light. So that circularly polarized light will be passing through this specimen. Then the loading which happens on the specimen will exhibit isoclinic fringe patterns. That isoclinic fringe patterns can be observed through the analyzer. Finally, when you analyze these fringe patterns, for each fringe pattern you take what is the load applied. Each load will signify the fringe constant. So when you determine each fringe pattern using the formula in your lab manual, F sigma equals to 8 into dP by dN. dP by dN is nothing but, from a graph you will plot load on y-axis, n fringe order on x-axis, then the straight line you take the slope of that is dP by dN. So 8 into dP by dN divided by pi into d. D is nothing but diameter of the disc. So using a vernier caliper, when we measure the diameter of the disc, it is 100 mm. So this is the setup. So when you come from the front, you can just see there is fringe patterns that will be observed. So you can just see fringe patterns. So when load is applied, there will be formation of fringe patterns. So I am applying load, you can just see there is variation in the fringe. So you can just clearly see that there is change in the fringes. So this is isoclinic fringe pattern. The moment you see the fringes, that is where you have to take the load. For example, you can just see two fringes which are very clear. So further when apply load, you can just see there is separation of the fringes. Thank you very much.